So I wanted to begin doing some initial voltage regulation tests on the system. So what I've got is my Rigol DP832. It's off to the side, you can't see it, and it's set to 8.5 volts output and clamped at 1 amp, or actually at half an amp, looking at it. And if I turn the output on, we can see that we're bringing ground into the back plane on this side, and the plus 8.5 over here on this side. Looking at the back of the back plane, you'll see these really heavy traces. And that's where the ground and the 8.5, 9 volts is brought into the cards. And so I should be able to get over here to these 2 pins here on the connector and see the DC voltage all the way across here. So these outer 2 pins here on this side are the supply to the 7805s, 8.5 or 9 volts. And of course the 2 edges down here are ground. So what we want to do is go ahead and power off the output on the supply. I've added a 5 volt regulator onto the partially built CPU card, and I'm going to go ahead and install it. Voltmeter ground is clipped on back here, so we just have a constant ground reference across everything. And I'll set this card up, hopefully. I need something else to help hold it up flush, so you can at least get a view on it. So the card is in. We turn on the power supply, and there's 8.5 volts. It's drawing no current. And we should see the 8.5 volts coming in here on this pin, coming up to the voltage regulator. And hopefully we've got 5 volts over here regulated out. And yeah, 4.9, it's close enough. And then on typically the upper, with pin 1 here, usually you've got ground down here, and this corner up here is usually VCC, so I should see on every socket the power supply voltage, or the regulated voltage. Now sometimes the pinout is different, but I think these are all stock kind of normal TTL devices. So this upper corner up here should be plus 5 on everybody, and it is. This is always a good test, really, before you plug the ICs in and test anything. So I don't know the pin out of the 8080 or the 8212, and I could poke around, but I'm satisfied that at least the build so far on this card, I've got voltage regulation and things look good. So let's go ahead and flip this back up. I've turned the power supply off and pull the partially built CPU card out. And let's go ahead and put that front panel interface card in. And we'll do the same thing. So power supply's back on. I should see 8.5 volts down here, and I do. Coming into the voltage regulator, I should have 5 volts coming out, and it's spot on 5 volts. And I should see the same thing here. We're on this 14 pin device. Pin 14 is VCC. VCC. On this 16 pin socket, it'll be pin 16. So just from a quick look here, just a poor contact on the probe, and it was. This is looking good. This is what I expected to see. I think that's the PIC processor, and I don't know the pin out on it. It is the PIC processor. So it's got a VCC on a different pin, which is why we didn't see anything there. I guess I could look in the schematic and figure it out, or at the data sheet. But I'm pretty confident that we're good here. One side or the other of this spiking cap should have the plus 5 on it, I would assume. Yeah, there it is. It's over on this side over here. So that looks good. We've got local regulation on the board. We've got 5 volts pretty much every place we expect to find 5 volts. So it's a really nice test. We're at least getting contacts on this front connector through the edge pins out there. So I mean, this is definitely a step forward. So I think the next step is I will populate this card and see if we can get the front panel to at least light up. There'll be no computer behind it, but that should be interesting. So I've populated the interface card here with all the logic, verified the parts are in the right places, pin orientation, powered it up, just checked that I still had 5 volts on it, which I do. I dug through my ribbon cables and found this 50 conductor ribbon cable that was already made up that actually seems to work well here on both sides. And I'm going to go ahead and apply power. I don't expect it to do anything. Some LEDs will light up. I don't expect the state machine on the interface card to run because none of the clock signals are on the back plane or anything. This is just sitting very static, but I hopefully will see a few of the LEDs light up. So let's go ahead and see if anything happens with power applied. And so we see a little bit of data activity here. That's kind of interesting. That's about all I'd expect to see. There's no processor behind this to do any real work. But this is at least an indication that we have power getting over onto here. We can actually verify that on the voltmeter here. So let's see, either that pin's going to be +5. That's really low. Oh, measure that again. If that's supposed to be +5, it is really low. I'm on the back side of the board here. Or would there be +5 on here? These pull-up resistors. I'm only getting about 3.4 volts down to the front panel, which isn't good. It's not going to be enough for the logic to wake up and run. Okay, that's not a good sign. It's saying we've got significant voltage loss occurring in the ribbon cable, and I don't know the orientation of the ICs I'm poking at here, but these pull-up resistors are all ganged together, and they're pull-ups. I would expect to be seeing Now I've got the red stripe, the wrong orientation on. I just got reversed here to what it would normally be plugged in. With some of the LEDs lighting, it says I've at least got power, the right polarity coming in. But no, I would expect to see a solid 5 volts or very close to what occurring here on one of these corner pins of these ICs. And it looks like we're getting 3.7 is all, which is really discouraging. There's one of the spiking caps. Let's see if we can find the power supply is not in compliance. Yeah, we're drawing 150 milliamps at this point, and the supply is set to half an amp, or an amp to, what's the power supply? Yeah, it's set to half an amp, and we're pulling 150 milliamps, so it's not like power supply going into compliance. Have I got 5 over here? Oops, no, that's the right place. The ground lead has come loose down here for the probe. See, now we see 5 volts here. Hopefully I'll see 5 volts here now. Nope, still got 3.5. We're getting a large voltage drop in the ribbon cable, much larger than I would expect. Which is not a good thing. is not what I expected to see. The vent supply is off. Take a peek at this ribbon cable. No, it's been chewed up, so it's actually got some broken traces in it, which might be part of the problem. Let me go dig for another 50-pin cable, see if I got something else. So I found a different ribbon cable. This one's in much better shape. It's really long. It doesn't have the notch for the keying, so I just made sure to get pin 1 indicated by the little arrow there in the plastic, to pin 1 in the plastic over here. And hopefully you can see the voltmeter. I'll leave the ground plugged in. Let's see if we're now getting a solid 5 volts on the front panel. So the power supply is on. It's actually drawing almost 300 milliamps here. That's a good sign. So hopefully I'll see +5 right here, or very close to it. There it is. So I had a bad ribbon cable before. The other interesting thing here is now all of the data LEDs light up, and I would expect that because the data bus is floating. We've got TTL inputs looking at the data bus, and an input will pull itself high. So that's no surprise to me. I don't know why the addresses haven't floated high as well, but that may be normal. Actually, that's probably normal as well, but this is a good sign. At least we're getting some LED activity. I like the intensity of the LEDs, so I think the little higher current limiting resistor wasn't a bad thing. I'm looking at them straight on. They're not overpoweringly bright. They, to me, are very reminiscent of what I remember red LEDs looking like when I was a kid, at least a teenager. So let me just poke at a couple other places on here where I believe I should see 5 volts. I think that one of these pins, I keep forgetting, I don't know the orientation because I'm on the back side of the PCB. Did I pull the ground loose again? No. I got +5 over here, I do. Again, on these pull-up resistors, 4.9, there's a set of pull-up resistors over here. There's a set over here. And there should be a pin on these TTL devices, which has got the power supply rail. There it is. So that pin's power supply rail. That pin should be a power supply rail. That pin should be a power supply rail. That pin. There it is. This pin. That's all 5 of the ICs. I've looked at the 3 sets of pull-up resistors. So we've got our 5 volts to the front panel. We've got some LED activity. I'm pretty happy so far. I don't expect this to do anything more until we've actually got an active processor on it, generating the various clock signals, and then the state machine pick over here on the interface card that you really can't see. You can actually bring it over into frame here. The PIC processor here that implements the state machine that drives all this will then have incoming signals off the bus to drive. But this is a pretty good test. I don't have the plus and minus 16 volt rails on here. No, excuse me, I don't need them for this test. I will need them to get an 8080 processor running. That's something we'll tackle in a future video. So I'm going to wrap this kind of front panel initial power up test up here. I'm happy with what I see. So we'll talk soon.